precision. We're going to talk about that one first. The precision, I want you to underline that word. Precision of a measurement. If they're asking you which one is more precisely measured, here's how you determine it. It has to be the smallest unit or fraction of a unit used. So if I measure something in feet versus inches, which one is more precise? If I just talk about measuring it to the closest foot versus to the closest inch, which would really be more precise? Inch, because inches are smaller than feet, right? Okay, well, we're going to have to be a little, they're going to give us actual measurements, and we're going to have to decide which of them is the more precise by comparing them. So in A, they have 16.7 kilograms compared to 16.66 kilograms because they're both measured to the same thing. They're both measured to kilograms. Now we have to decide which one is more precise between those two measured to the same thing. Which one's measured to a smaller unit? Cody?
Well, if you have 1666, that means it has a repeating decimal, right?
Chances are, but not necessarily.
And with the
they might have just rounded it to 66.
And with the 16.7, wouldn't you want to have 16.7 because it's a nice decimal?
Okay. But precision doesn't talk about niceness. Precision talks about smallest. Remember, smallest unit. So notice what they say here. 16.7, that's 7 is in the tenths place. That's measured to the nearest tenth. 6.66, that one's measured to the nearest hundredth. What is smaller, hundredths or tenths? Think of it as like money. What is smaller, pennies or dimes?
Pennies.
Smaller? I'm not talking about it the size of the coin. What is a smaller measure, a penny or a dime? Pennies. So hundreds are smaller than tenths. Measured out to the smallest unit. Just like inches are smaller than feet, hundredths are smaller than tenths. Give me something that's even smaller than hundredths then. Thousands. And so as we keep, going out with the decimal, behind the decimal, as we keep going out behind the decimal point, we're going to smaller and smaller units of measure. Okay, and then in the other example B, they have 8 5/10 kilometers compared to 8,532 meters. And notice that units are different. So we can't compare them. If we just said right now, if I asked you which one is a smaller unit of measure, a meter or a kilometer, which one is smaller, a meter or a kilometer?
A kilometer.
Really?
No.
Here's a meter stick. A kilometer is kind of like equivalent. When they talk about it in Europe, how far they drove or how far they walked, or they talk about instead of miles, they say kilometers. Kilometers are a lot longer than meters are. Okay. In fact, anybody know how many meters are in a kilometer?
1,000.
1,000. Okay, so meters are a smaller unit of measure than kilometers, but we can't compare them that way because they aren't both measured to the ones place. If they were both measured to the ones place, then we could say, okay, well, meters are smaller than kilometers, so the meters are more precisely measured. But kilometers are measured to the tenths, and meters are measured to the ones place, so we have to convert and then make a comparison. So you were right, here's our conversion. There's 1,000 meters in a kilometer. So what they did is they changed the meters into kilometers, and to do that, because there's 1,000 of them in a kilometer, they just moved the decimal point back 3. That's just like dividing by 1,000. And now we can compare them. We say we have 8.5 kilometers. The meters changed to kilometers is 8.532. So this is measured to the thousandths place. This is only measured to the tenths. So now we would say, you know what? The 8,532 meters is a more precise measure because then when it's changed to kilometers, it's measured out to a smaller unit of measure. Okay, let's just do some practicing and see if we can figure this out. Choose the more precise measurement in each pair. We have 73.71 centimeters and 736.2 centimeters. First thing you're going to look at is, are they both measured to the same type of measure? So we got centimeters and centimeters. Do we need to do any converting? No, we don't need to do any converting. So the next thing we do is then we say 73.71 centimeters. That is measured out to the nearest what? 100th. So 100th of a centimeter. 736.2 centimeters is to the nearest 10th of a centimeter. What's smaller, tenths or hundredths?
Hundredths.
Hundredths is a smaller, hundredths. Let's write this out. Hundredths is less than tenths. We want the smallest unit of measure. We want the one that is the least, or the smallest, measured out to the smallest. So hundredths is smaller than tenths. So we're going to say which one is more precise. The 73.71 is more precisely measured. So it was taken out to the hundredths place rather than the tenths place. So they just got it a little bit closer to its precise measurement by doing that. So it's kind of like saying, if I want you to measure the length of this room, and I give you a meter stick to do it, and I have some of you measure it to the nearest centimeter, and others of you to the nearest millimeter, whole millimeter, whole centimeter, who's going to have measured this room more precisely? The people measuring it to the nearest centimeter or to the nearest millimeter? To the nearest millimeter, because those are smaller unit of measure than a centimeter. Okay, let's look at number 2. The first one is measured in milliliters, the other one in liters. Okay, so if they're not measured in the same thing, the next thing we look at is, are they measured to the same place value? Well, this one's measured to the ones place, and that one's measured to the hundredths place. So we're going to have to do a converting. They're not measured to the same place. So we're going to, let's convert 4,732 milliliters into liters. Anybody know how many milliliters there are in a liter? Cody?
100.
No. 1,000. There are 1,000. So let's write that here. There are 1,000 milliliters in 1 liter. There are 1,000 milliliters in 1 liter. So now what we're going to do is we're going to convert that 4,732 milliliters into liters. How do you think we are going to do that? Do we need to divide by 1,000 or multiply by 1,000? Okay, if we multiplied by 1,000, we'd add 3 zeros to this. So we would say that we're changing it into a bigger thing. We're changing them into liters. Would we get more of them then?
No.
No, we should have
Less.
We're going to move the decimal. We're going to move the decimal point back 1, 2, 3. So it is 4.732 liters. Okay, I think one of the things that what you might have to do is go back to that conversion factor thing that we did. Remember when we said, if I want to change 4,732 milliliters, I put it over 1. What do I have to do? Do I put milliliters upstairs or downstairs in my conversion factor? Downstairs. So milliliters, there are 1,000 of them in a liter. Oh, look at there. We're going to divide, aren't we? Yeah. So when we divide by 1,000, that is the same as moving the decimal point back 3 places. Okay, so what is it now out to? What place value is that? 1,000th. To the nearest 1,000th of a liter. 3 decimal places behind the decimal point takes you to the thousandths. And let's talk about the other one that was already in liters, 4.73 liters. What's that one measured out to? The nearest what? What's this 3?
Hundredth.
That's the hundredths place. 100th of a liter. So which one's smaller, thousands or hundreds?
Thousands.
Thousands, let's put that over here, thousands is less than hundredths. So we're gonna go and say, okay, which one was measured to the nearest thousand? The 4.732 liters, which started out as what? Started out as 4,732 milliliters. That's the more precise one. We had to do the conversion to compare them, but in reality it was measured to milliliters, but it's still more precisely measured. Okay, so if they're measured to the same thing, centimeters, centimeters, inches, inches, quarts, quarts, then we can just see which ones taken out to the smallest unit of measure. We don't have to do a conversion factor. If they're not measured to the same thing, then we have to do a conversion factor, a conversion to help us get them in the same, and then we can compare which one's measured to the smallest. Okay, anybody have any questions on either of those? Anything about precision right now? Because we're going to move on to include accuracy now also. So any questions on precision? Measured to the what?
Smallest unit or fraction.
Smallest unit of measure. Okay. Now let's talk about accuracy. Let's underline that. The accuracy of a measurement. What's different? That's the closeness of the measured value to the actual true value. So underline, circle, show yourself. Accuracy means something else. Accuracy does not mean measured to the smallest unit of measure. It means how close is it to what you really wanted it to be. Okay? So we have this number 3 here. A 45-pound object is weighed on 3 different scales. The results are shown in the table. So let's first deal with the. We're gonna do the most precise one first, and then I'll teach you how to do accuracy. So scale 1, they're all measured to pounds. They're all measured to pounds. So we get to just compare what they measured out to. So scale 1 is measured to the nearest what? What is this? Tenth. Okay, nearest tenth of a pound. Scale 2 measured this object to the thousandth of a pound. And scale 3 measured it to the nearest hundredth of a pound. Okay, of those 3 measures, which one's the smallest unit of measure? Thousandth of a pound. So which scale is the most precise? Scale 2. Okay, and there's our support for it. We wrote up here what they were measured to, and so our support is that, and we say scale 2 is the most precise. So you have to support your answers in tomorrow's homework. You don't get to just take a wild guess and put something down. Okay? Now we have to do which scale is the most accurate. Accurate is not measured to the smallest unit, it's closest to what we want it to be. So notice what they say up here we need to do for that. For each measurement, find the difference between the actual and the measure that was taken. What does difference mean? We're going to do a subtraction problem, yeah. Okay, so and what we're going to do is we're going to always start with the bigger of those 2 numbers. So whether it's the actual that is bigger or what the measure was, whichever one's bigger, we'll start with that in our subtraction problem, so we don't end up with any negatives. So for scale 1, let's do scale 1. We have the actual is 45. It was measured 44.9. Which one's bigger? 45 is bigger than 44.9, right? So we'll start with our 44, or 45 I mean. We'll subtract the 44.9. And it's kind of like saying if you have $45 and you give away $44.90, how much do you have left? 10 cents. That'd be 0.1, wouldn't it? Okay, so we have 0 and 1/10, and those are pounds. Okay, so scale 1 got within 1/10 of a pound, it got that close. Scale 2, which number should we start with in our subtraction? Well, which one's bigger? Is 45.105 bigger or 45? Yeah, the measure that they did is actually bigger. So we'll start with that one again, like I said, so we don't end up with any negatives in our answers here. So 45.105, take away 45. What's that? 0.105 pounds. That one got within 0.105 or 105 thousandths. Okay, you know what we're going to do with this one? Because this one's the thousandths, we're going to put 2 zeros here so we're going to be able to compare easier. So that one got within 100 thousandths of a pound. This one got within 105 thousandths of a pound. Which one's closer right now? This one is closer. If you have 100 out of 1,000 and 105 out of 1,000, which one is closer to 0? The 100. This one is closer right now, but we still got one more scale to do. Okay, so we have 45.01. That's bigger than 45, so we'll start with that. It's $45 and a penny, subtract $45. A penny. And let's make that into thousands. Let's put a 0 there so we can compare again. This one says what? 10 thousandths. 10 thousandths. Which one's closest? Yeah, this one is the closest to what the actual. This is only 10 thousandths of a pound away. This is 100 thousandths of a pound away. This is 105 thousandths of a pound away. So this one's only 10 thousandths of a pound away. It's the closest. So we're going to say this one is closest. So we're going to say scale 3 is the most accurate. Most accurately measured it. Okay, so accuracy and precision mean 2 different things. Precision means which one's measured to the smallest unit. Accuracy means which one is measured to the closest to what you wanted it to be. And notice in this case, one scale was the most precise, the other was the most accurate. One scale could have been both of them, but it didn't have to be, because they mean 2 different things. So, any questions about accuracy? That was a new thing we added down here. Think you know what kind of work you need to show for these? On your homework? You don't just get to answer, oh, I think this one's most accurate. What's going to support it? Okay, let's go to the back then. We got one more thing we're going to talk about. We're going to talk about tolerance. Tolerance describes the amount by which a measurement is permitted to vary. So let's underline tolerance. And let's circle this part. Permitted to vary from a specified value. So if your parents tell you that you have to be in the house by 10:30, give or take a half an hour, they're giving you a variance, aren't they? They're saying, you know what? It can vary, though. We're not saying you have to be in here at exactly 10:30 or else. We're giving you a variance of a half an hour either way. So that means they'll tolerate half hour before or half an hour after, right? So they would tolerate you being in at 10, anywhere between 10 and 11 o'clock. But their ideal was they wanted you there at 10:30. That's the ideal. But they were willing to say, you know what, I'll give or take a half an hour. Okay, so the range, when we talk about a range of values, that 10 o'clock to 11 o'clock is the range. But 10:30 is when they really wanted you there. So look at this one right here. We have 50 kilograms plus or minus 2%. In other words, 50 kilograms is what they want it to be, but they're willing to let it vary by 2%. So what we have to do first is we have to figure out what is 2% of 50 kilograms. So step one, we're going to multiply, we're going to change, would you write this up there? Change 2% to a decimal. You can't work with it, when something is a percent, you can't work with it as the percent, with the percent sign, just drop the percent sign and use the number. It'd be nice if you could. But you have to change it to a decimal. So the decimal name for 2% is 0.02. So the first thing they did here is they figured out how much can it vary by. So let's put this here. It can vary by 1, and these are kilograms. It can vary by 1 kilogram. So in step 2, you're going to figure out, you're going to do subtraction and addition problems. So 50, add the 1, there's where we get 51. 50, what they wanted it to be, take away that 1 is 49. And then notice what they did in step 3 when they wrote the range. They go from smallest to largest, the smaller to the largest. So the range, the tolerance range for this is from 49 kilograms to 51 kilograms. So we're going to, if it's given to us as a percent, we're going to figure out what percent, when we have to calculate that percentage of what it can vary by. Then we have to add and subtract it to what we wanted, what was the middle, what was the ideal, and then we write the range. Okay, let's do a couple on our own here. It says, write the possible range of each measurement, round to the nearest tenth if necessary. So in other words, if when you're calculating that percentage, if it doesn't come out to tenths place, we're going to round it to tenths. So we're going to take step 1. Write this. We're going to do, we have to take 50 and we have to multiply it by whatever 4% is as a decimal. What is 4% as a decimal? Let's okay. Yeah, 0.04 because you got to move it back 2 places. So it's times 0.04. So what is 50 times 0.04? 2. Okay. So 2 is how much it can vary by. And these are 2 kilograms, aren't they? So it can vary by 2 kilograms either way. So in step 2, that's where we're going to do our addition and subtraction problem. It starts at 50. It can go up by 2. It can go down by 2. So 50 plus 2, 52 kilograms. 50 take away 2, 48 kilograms. Step 3, we write our range. So what's our range? Here we start with the smaller one and go to the bigger one. It can go anywhere from 48 kilograms. That isn't minus, that's a dash, that's like a 2 sign. 48 kilograms to 52 kilograms. That's the range for this tolerance. Okay, anybody get questions about that one? Okay, then let's move on to this next one here. We're going to be, first thing we're going to do is let's write down our 1.5 and change it to a decimal. What do we have to do with that to change it to a decimal? How many places? 2. 2 in what direction? Left. To the left. So we have to go 2 this way. So this is what?
0.05.
Yeah, 0.015. Okay, so we were going this way. Sometimes it's good to put an arrow so you can show yourself where were you actually going. Okay, step 1.
Do you always want to change the percent to a decimal?
Yep.
The decimal to
The percent to a decimal. If it's given to you as a percent, you always want to change it to a decimal for your step 1. Okay? In step 1, we take that 125 and we multiply it by that 0.015, excuse me. We multiply it by that to figure out how much can it vary by. And this is, if I'm thinking this one, we're going to have to round to the nearest 10th, because it's not going to come out nicely like the last one did. So what does this one come out rounded to the nearest 10th?
1.75.
Okay, 1 point what?
875.
Okay, so if it comes out to 1.875, rounded to the nearest 10th, what's that? 10. The 8 is in the 10th place. Does the 7 change that 8 to a 9?
Yes.
Yes, it does. So we'd say about 1.9. So it can vary by approximately 1.9. So we found out how much it can vary by. Step 2. This is where we do our what? Adding and subtracting. Our beginning number this time isn't 50 though. Be careful. It's 125. So 125 plus that 1.9. 125 take away that 1.9. I'm gonna put my labels here. Pounds this time. So did you get the same ends I did? You can go up as high as 126.9 and as low as 123.1. Do we agree? Okay. Step 3. This is where we actually write the range and we do it from least to greatest. So 123 and 110. Oh, I changed how I'm writing my 1 there. These are pounds to 126 and 9/10 pounds. Notice we have our labels in there also to show what is this range about. So this is the kind of work you have to show to support these problems. Okay, any questions? Okay, then